Hi there once again, and welcome back to my channel. And it's all about differentials versus implicit differentials. So why are we studying these concepts? Because all throughout our lives, we have been fully exposed to what we have come to know, which would be the explicit functions. So you can see in this column a list of functions in which you can automatically know that this would belong to the x, this would belong to the y. So these are called explicit functions. And one example, or let me give you more examples to that. So y is equal to cosine of x, we have y is equal to ln of x. So when we solve these problems, we already go directly to the process because we don't need any more to separate the two. So explicit functions, for example, this can be written as y is equal to x plus 2. This can also be y is equal to square root of x. And also for this function, y is equal to 1 over, let's try to extend it, x plus 2. So everything in here are explicit functions. So let's modify this a bit. So when we encounter problems in which the x and the y belong to one monomial, or they can't be separated no matter how much you factor them out. So for example, from this version, we can create something that looks like this. So y is equal to xy plus 2. Same thing with this. We have here y is equal to square root of xy. And then for this one, we have y is equal to 1 over square root of xy plus 2. So I just really made these very easy, very accessible, so that you would understand how it's being made. So our goal, let's choose another pen. Our goal is basically to solve for the derivative. So solving for the derivative is a process that can both be applied to explicit and implicit differentiation processes, but all the while we all were exposed to the explicit. But this video also can help you solve for functions that have the x and the y variables just sitting next to each other. So let's first have a problem that involves this one. So we have your y. So for example, we have here the function. So y is equal to x plus 2. So when we get the derivative, so we would obviously have to put this punctuation, and then we all know that the derivative of x, so d of x would always be equal to 1. So that would mean that the derivative of this function would be equivalent to 1. So let's make 3 columns for this. Let's make a bit of a shortcut. So we have here y is equal to x plus 2. Then we have here the derivative, which will be y prime equal to 1. And what if we have the implicit version? So it would mean that we have y is equal to xy plus 2. So the general rule when we are getting the implicit would always been the dy over dx. So that's our goal. So try to look at how I actually did it. So when you say y, it would be y prime equal to, let's get the derivative of xy plus the derivative of 2. So take note that we are just actually adding, and it's part of the properties of solving for derivatives. So in this case, we are getting the differentiation of y with respect to x. So we need to write this because we all know that y y prime is equal to dy over dx. The same thing with your f prime of x, where your y changes with respect to x. So trying to simplify further, so we know by this rule, let's choose another color. We know the u dv plus v du, so we can always attribute, let's just erase this first, u as x and then v as equal to y. So y prime is equivalent to x derivative of the derivative of your y plus your y derivative of your x plus the derivative of a constant 2. So now we all know that the derivative of y would be equivalent to 1, but then we also need to get the derivative of that value. So it's like the chain rule. So let's just put that here a bit. So we know that 1, let's say y raised to 1. So if we get the derivative of that, so we put this here like how a coefficient looks like, 1 times y to the power of 1 minus 1, then you get the derivative of this. And since we know that getting the implicit differentiation, our main goal is really to get this thing here, this dy over dx. So that's the point I'm trying to lead you to. So it would be equivalent to x y prime plus then the y, just copy it, then the derivative of your x would be equal to 1. So now, why are we not getting the x prime in this case? So obviously, our goal is this, dy over dx. So with respect to a change in your x. So we only focus on the y to make things really simple. And then plus the derivative of a constant would be equivalent to 0. So yeah, we should not forget as well that this y prime here is also equal to, we just have to copy that. So y prime is equivalent to xy prime plus y. Then we can move it here or transpose to this side. Let's go to y. We can factor this. 1 minus x is equal to y. Then y prime is equivalent to y over y, or y over 1 minus x. So that is entirely different compared to the implicit. I mean to the explicit. So the explicit, we had y prime equal to 1. So that was pretty easy. But for the implicit, we had it y prime is equivalent to y over 1 minus x. So our basic premise will always hold true, that dy over dx changes. So going to the next problem, so the function would be y equivalent to square root of x. So this would be the, let's have it in this way, and the implicit. So we have our y is equal to square root of x, and for the implicit we have our y is equivalent to xy. So let's first take the derivative of this one here. So let's choose blue. Y is equal to square root of x, so we know that we can still apply the chain rule. So the derivative of a variable raised to an exponent, we have here n times x to the power of n minus 1 times the derivative of your x. Let's put the punctuation there. So this one here, we can have y prime, or let's make it more simple, y is equal to x to the power of 1/2. So the y prime would be equivalent to, let's put this down, so this will be made as a coefficient, just like how this was brought down here. So 1/2 times x, 1/2 minus 1, then we get the derivative of this variable here, this guy here. So 1/2 times x to the power of negative 1/2, so 1/2 minus 1 is negative 1/2, and the derivative of x would just be equivalent to 1. And then when we want to simply simplify this entire function, we can have 1/2 square root of x. So this would be the y prime. So there's really this would be the value of the derivative of y is equivalent to square root of x. So let's now go ahead with y is equivalent to square root of xy. So take note, this is implicit. So it's very important that you know whether, or that you can identify if this is an explicit function or if it's an implicit function. So the implicit function, the x, you can find two variables just in one expression, or just in one monomial in this case. So what we do, we know that y prime is equal to dy over dx. So here we get the derivative in both sides, so y prime is equivalent to derivative of your xy to the power of 1/2. So y prime is equal to 1/2 times square root of xy. Then we get the derivative of your xy here. So in this part, there's no longer the 1/2 because it has already been applied in accordance to the chain rule. So this would be another case that involves the chain rule, is what I've written earlier. So x y prime plus y, and the derivative of x would be 1. So simplifying further, y prime is equal to 1/2 square root of xy times xy prime plus y, and then trying to simplify, so 2 square root of xy times y prime is equal to x y prime plus y. So why we're doing this? It's because we need to factor out all the y prime. So we can't conclude that this would be the final answer, as you can see that because obviously y prime is here, y prime is still here, so it's all over the place. So we need to always organize our solutions. So let's move in for xy prime is equal to y. So be careful in transposing this because some students actually still put positive. So you need to change the sign when you transpose it to the other side. So factor out the y prime. So it has been our goal right from the start to factor out the y prime. So it would be easier for us. Minus xy minus x is equal to y. So your y prime would be equivalent to 2 square root of xy minus x. So this would be the final answer. And this would be in contrary to y prime is equivalent to 1 over 2 square root of x, which is an actual derivative of an explicit function, which is y equal to square root of x. So there's really a huge disparity between this and also this. And moving forward, so we have this function. Let's choose another color. Let's go back to black. So we have y is equal to cosine x, and we know that this is rather explicit. Let's choose cosine of x y as our implicit. So as we get the derivative of the explicit function, we get y prime equivalent to negative sine of x, then the derivative of your x, which would just be equivalent to 1. Y prime is equal to negative sine x times 1. Obviously, y prime is negative sine x. And getting the derivative of your y, the implicit function. So let's choose this color. Y prime is equal to negative sine xy times the derivative of your xy that's inside, or we also call this as your theta, or the angle that it subtends. So y prime is equal to negative sine xy times x y prime plus y. So this is your u dv plus u plus v, sorry for that, plus v du. Okay, and y prime, let's have xy plus y prime. If we try to, we can always, the next best thing to do would be to distribute this one. So xy prime plus, plus negative sine of xy times y. So the y is here. So let's try to factor out y plus, let's transpose this function here because we want to get rid of y prime, so plus sine xy of x y prime equivalent to negative y sine xy. So factoring it out, 1 plus sine xy, sorry, let's have it x sine of xy equal to negative y sine xy. And next thing, y prime is equal to negative y sine xy over 1 plus x sine of xy. So that's how it goes. So this would already be the final answer, but since we want the negative sign to be always be in the middle, so it would be y sine of xy over 1 plus x sine of xy, and this will be your final answer for your implicit differentiation. So if you've got comments, if you've got suggestions on how to make this video better, I would surely love to know your thoughts about it. And just write down the comments below so I can have better videos and help those who still need help, especially in this aspect. Bye.